Hello, welcome to everyone to this new tutorial of Copernicus services. This tutorial is presented in the framework of the WEkEO training workshops. In this case, the topic is forest monitoring. So in today's session, we are going to make an example of assessment of emissions and air quality impact from forest fires. My name is Álvaro Pascual Collar. I am oceanographer in Now Systems, and this tutorial is presented in R programming language, so we are going to use the integrated development environment RStudio. Well, going directly to the contents of the tutorial, here we have downloaded the folder of the tutorial, and here you can see that it contains three different elements: a folder called data, where we have already downloaded the data you will need for this tutorial, so there is no need of downloading any data from Copernicus services. You can just run the tutorial from the data you already have in this folder. And here you also have the R script that we will explain today, and also the documentation of the tutorial in PDF format. Here you can see the documentation. In this documentation you will find all the information you need for running this tutorial. As I said before, we are going to make an example of assessment of emissions and air quality impact from forest fires. In today's session we are going to focus this analysis in the region of the Iberian Peninsula. Along this tutorial we will cover these sections. First, an introduction where we will explain a little bit about the emissions of pollutants in wildfires, and we are going to explain the data sets we are going to use in this session. And also after that we will jump into the sections where we are going to work with our code in this tutorial. First, we will learn how to set up the environment, our environment, learning how to install the packages needed, and also load the packages. And after that, since we are already prepared our environment, we are going to learn how to access the data. As you will see, we are going to work with netcdf files in this tutorial. So we will learn how to use our library to open netcdf files and access the data. And after that we will start to work with data, plotting some variables, the air quality variables of the data sets. So we will jump into this section where we are going to plot climatic values of all air quality variables downloaded in these datasets, included in this dataset. So we will learn how to compute the temporal average of any variable inside the dataset, and how to plot the maps in different formats, including information of different sources of information, and also including different variables in the maps. And after that we will start to analyze specific events of wildfires. So we are going to first make an average of the specific dates of the event of a wildfire. So we will get the mean air quality the mean of the air quality variables in these specific events, and we will plot this result. And after that we will do almost the same, but instead of using the average, we will learn how to compute the anomaly values. So we will get some other information, and we will get specific information associated to the event we are studying. Well, as introduction, I would say that obviously the wildfires has a lot of socioeconomic impacts. Among them, it is included the emission of different pollutants like carbon monoxide, nitric oxide, nitrogen monoxide, carbon dioxide, and obviously particulate matter. And well, in this tutorial we are going to use these variables, and we are going to study these variables in the case of in some cases of wildfires. We are going to focus in the Iberian Peninsula in two cases. So in the Iberian Peninsula, the wild forest of Pedrogal in 2017, it was in Portugal, and also a wild forest in Spain in the region of Losacio in 2022. And to do this analysis, we are going to use two different Copernicus datasets. These Copernicus are provided by the Copernicus Atmosphere Monitoring Service, CAMS. And these services provide, for example, these two products. For example, we have the reanalysis product, the air quality reanalysis product. So this is a reanalysis product generated by modeling, numerical modeling, and it gives information of air quality. And we are going to use also this product that contains not air quality values, but emissions. And these emissions are computed from teledetection sources. So it provides biomass burning emissions based on fire radiative power, right? So these are emissions of pollutants associated to biomass burning that could be associated with wildfires, or maybe not, but usually it's very strongly linked with the emissions associated with wildfires, right? Well, here you have a table with the specifications of the data we are going to use today. As you can see here, we have the two products, and we are going to use the same specifications in terms of the period of time, frequency, latitudes and longitudes range. The window of study domain is the same, and also we are going to use the same period of analysis and the same frequencies. And this is because this tutorial is presented in the way that you can run first the tutorial using one data set. So you will get some information and you will get some conclusions, and after that you can run again this tutorial, but using the other data set. So you will get more or less the same conclusions, but since the data sets are not exactly the same, this data set contains information of air quality, and this data set contains information of emissions, of pollutant emissions. You will get similar information, but obviously it will be different. It will give you different conclusions and different information, right? Well, this data set, as you can see here, for the case of reanalysis, we are going to use these four variables. This, as you can see, we are using four different pollutants, but we are using the variable of total column, that is, it is associated with the integrated concentration of integrated amount of these pollutants in the air column. And we are going to use, in the case of data set of emissions, we are going to use these four different variables that includes the emissions associated to biomass burning of carbon dioxide, carbon monoxide, nitrous oxide, and also particulate matter, PM 2.5 in this case. It's important to note that since I am explaining this, because I think it's very important to know what data sets we are using in this tutorial, and there is no need of downloading any data from data viewer in Copernicus services, because the data, as I said before, are already downloaded in this tutorial. You should have these two files in the tutorial that contain the data for the emissions reanalysis, for the emissions dataset and the reanalysis dataset, right? So you don't need to download data. This tutorial, we are going to focus how to use the data, not on how to download the data. But well, I am also included here the links for since it is really interesting to know what products are you using in in your studies, I include here the links for the products to the data viewer. Here you can see the information, so you are redirected from these links. You are directly redirected to the web page of the data viewer, where you can get the full information and the full documentation of these two products, right? Well, continuing with this tutorial, we start here with the part of the tutorial that starts to explain parts of the code in our programming language. So from here, I will jump into RStudio. If you go to the R script and you double click on it, RStudio is automatically opened. The script, here you have the script, and you can see it contains some different sections. The tutorial setup, accessing data. These sections are related with the documentation, so you can check all the information of these sections from the documentation. And here you have the RStudio environment. As you probably know, this RStudio environment contains this window that is the script of the window, the script we are working with today. And it contains this console, where it is our console, where you can type any R instruction. For example, you can type 5. We are including the number 5 in the variable a, so we can type later plus 1 is equals to 6, right? This is a console. So to run this script, you can run this the different lines of this script by selecting the lines and pushing Control Enter into your keyboard. So for example, as you can see here, I have executed this line that appears here, and it's automatically executed here, right? As you can see here in this tutorial, and here you have the bottom right panel, you have also a window of plots where we will get the plots we are going to create today, right? Well, this first section, the tutorial setup, you have different code lines. For example, you have the installation of packages, the packages we are going to need today. We have some lines devoted to load the libraries we are going to use today. In this case, it's very typical in this kind of programming languages that first you need to load the libraries or the packages you are going to use in your script, and this is something that is included at the beginning of the script. And also this instruction of installation of packages, it is only needed if you haven't previously installed these packages. So if you haven't previously installed these packages, you can run this instruction by selecting the line and pushing Control Enter. I am not going to do this because I have already installed these packages, so there is no need of installing them. And after that, you can run the lines of loading the libraries, giving the information to the system, to the creating your own environment with the libraries and the functions you will need here today. As you can see here, we are going to use these 4 libraries, our libraries. These libraries are mainly devoted, this netcdf library is devoted to access netcdf files, so it gives a lot of functions to access and write netcdf files. We are going to use it today to access the files of the datasets we are going to use. And also we have these 2 libraries that are devoted to This ggplot library is devoted to create plots, scientific plots in R. They are very famous libraries. So if you want to extend more information about the libraries we are going to use today, you can go to the documentation, and here I give you the links for the documentation of the different libraries we are going to use today, so you can get information, a full documentation of these libraries. Well, since we already have run these lines of loading libraries, we have already our environment is ready to start working, and we can jump into the next section, and it is devoted to explain how to access data. As I said before, we are using in this case netcdf files. These netcdf files are accessed using this R library, R netcdf. And this library provides different functions that will give us access, for example, the function open and see. Well, first, we will need to access the data inside the file is just open the file, right? So to do that, we use this function open.nc from our netcdf. And well, in this case, we have different code lines before this opening. As you can see here, but these lines are only parameters that we will use along this tutorial. For example, I have here a list with the location of the two datasets we are going to use today. These are the datasets. This is the name of the datasets included in the folder data. You can see here. This is the name of the datasets. So as I said before, this tutorial is designed so you can run the tutorial using, for example, the air quality data. So here we are defining a variable called work dataset. This variable has the value of CAMS air quality. So since this variable is defined as CAMS air quality, we are going to use this file of reanalysis data, but you can change this line for this one. So once this work.dataset variable is equal to CAMS emissions, you will use this emissions file, right? By now, as first running, I would recommend to use the air quality data, and after that, if you are interested on it, you can run again this tutorial using the emissions data, right? So, well, we can run these first parameters to get the information of the file we are going to use. As here we are defining the file name. So if we print a file name, here you can see that since we are defining that file name it's equal to the path of the reanalysis data. So that now we can use this open.nc file to open this file of reanalysis data, and also we will print this dataset. This opening creates an object called ds dataset. So this object acts as a pointer. So anytime we want to access to the data inside the file, we will use this object dataset to access the information, right? So we can use the function print.nc over the object ds. So we'll get a short report of the information stored in the dataset. Here we have, you can see in the console, we have received the short report of the information stored in this dataset. As you probably know, for those of you that are not familiar with netcdf formats, I can tell you that the netcdf format contains three types of objects. First object are the dimensions, the variables, and also there are attributes in the file. Yeah, the attributes are only information, like a header in the file. For example, you have the attribute convention or the attribute institution that gives you information about what institutions have created the file, or for example, the convention included using when this file has been formatted, etc. But you have also the dimensions, which is the declaration of the different dimensions included in the file. This file contains 3 different dimensions: valid time, latitude, and longitude. And as you can see here in variables, we have the arrays of data included in the file. You can see there is also variables, one-dimensional variables associated to each dimension. So in this variable called valid time, we will get the information, the array of data associated to this dimension that, as you can see, it has a length of 3,600 values. And we have also the value, the latitude and longitude dimension. And after that, we have some different variables like TCCO, TCNO2, etc. Here you have also different attributes associated to specific variables. For example, here you have the list of attributes associated to this TCCO variable. So if you study these attributes, you can get, for example, interesting information. For example, the long name that will give you what is stored in this variable called TCCO. We have the total column carbon monoxide, for example, here. So it's important to keep in mind that this variable is called TCCO. This is the name we are going to use to access the information of this total column carbon monoxide. And this is, for example, for the second variable TCNO2, we have the long name. It's here in total column nitrogen dioxide, and etc. We have also this TCNO variable that contains total column nitrogen monoxide, and also TCSO2 that obviously it contains total column sulfur dioxide, right? Well, this is interesting information from the file, but now we should learn how to access this information using the code and using some instructions, right? So here you have some information that gives you about how to access some lines devoted to learn how to access the data inside the file. For example, this is just a couple of parameters for this section, defining the file variable to work with var name. In this case, we type var name, we are going to work with this variable by now, just as default variable. So, for example, if we would like to access the information of this variable, we can use the function var.get.nc. This function from our netcdf library gives you access to the array of data of this variable, that in this case we are using the dataset as defining the file where it is stored, and also we have to include as a parameter the variable name, that is TCNO2, as we said before. So with this instruction, when we run this instruction, we create a variable called data, that if we print data, we see that data is an array including the full data of this TCNO2 variable, right? Well, additionally, for example, we can use this variable using different R commands. For example, we can print the dimension of data. And as you can see, data content is an array of three-dimensional array with the size of 22, 15, and 3653 values. As you remember, if we can print this information of the file we are using it, you can remember that our file had three different dimensions: valid time, latitude, and longitude, with this size 3600, 15, and 22. And you can see the data array contains three dimensions with the same sizes. And this is because, for example, in this variable depends on these three dimensions: valid time, latitude, and longitude, and using in this order. The order of this TCNO2 variable is of the dimensions. The order of the dimension of this TCNO2 is also given in the report of the file. Here you can see that TCNO2 depends on the dimensions longitude, latitude, and valid time on this order. So when you print the dimension of this array, you will get the size of the dimensions in this order: longitude, latitude, and valid time, right? Well, we can access the data using varget.nc, and also we can for example, access the data of the latitude values inside the file, for example, using the dataset, the varget.nc function applied to the dataset and using the variable name latitude. And here, for example, we can run these two lines, and if we print latitude and longitude, you can see we have here the set of latitudes inside the file and the set of longitudes inside. Here we have the set of longitudes inside the file, right? Okay. After that, we can do the same for time. For example, here you can see that we are getting the information of valid time from the dataset using the same function than before. But there is a little problem here, because as you can see, if we print the time, we get a sequence of values that doesn't seem to be related with time. This is because we can see here that time, for example, let's print again this dataset. If we go to the variable valid time, here we can see that the units of this time are seconds since 1970. So this result are amount of seconds from that date, right? So these time values are not very useful. So it's interesting to learn how to format these time values. So to do that, we are going to use here, we have a new function that is attribute_get.nc. This function allows us to get access to the value of an attribute. As you will see right here, we have the information of units as an attribute of the variable valid time. So to get this information in the file, we can use this attribute.get.nc function applied to the dataset in the variable valid time and using the attribute called units. So when we run this function, time unit, if we print this variable, we get the information of this variable that is the value of the attribute we have requested, right? This is interesting because after that we can use two different functions as date the mixing of two different functions as date and utcal.nc. This utcal.nc is a function from our netcdf library, and as date is our function. So using these two functions, and including in the functions the time unit and the values of time, we can create a new array date that if we print this date array, we get that the formatted values of time. So we get dates, specific dates for from our dataset. As you can see here, we have a dataset that starts in 2013 in January, and it goes up to 2015, right? Well, after that, we can work with this. No, sorry, this doesn't finish in 2015 because the printing of this result is only splitted, so because it has lots of values, right? It starts in 2013 January, and if we would like to learn to know what is the last date we have here, you can see here we have daily data for January 1st, 2nd, 3rd, 4th, 5th, and if we would like to learn to know what is the last date in this file, we can type something like length date. Oops, sorry, this is not here and here. Well, this is the last date included in the file, January 2023. Right, so we have learned how to format the time values from netcdf data file, and we have learned also here how to use a get attribute get.nc function. It's an interesting function that we can also use it, for example, to get information of global attributes in the netcdf file. Here we are getting information from another variable, the long name of the data, for example. We can print this value. For example, here we are getting the long name of the data. We explained before that this attribute is usually quite useful because it gives information about the data included in the array. And also we can use this variable nc global to access the global attributes inside the file. For example, here we are using the function accessing a global attribute not associated to any variable, it's only associated to the file. For example, we are accessing the attribute institution in the file. We can print the institution, so we can access the attribute of this global attribute, in this case the institution. Well, it's interesting to know this. But well, we have learned in this section how to access the information, the arrays of data, and also the attributes inside the netcdf file. After that, we can go to start working with the data. So we are going to have a first view of the data we have in our data set. As we said before, it contains 4 different variables of air quality. So we will learn how to compute a climatic average of the data, so we can plot these mean values of the pollutants. So air quality, the concentration of pollutants, for example, here we are going to compute a climatic average for this file, and to do that we can propose this function that we have called climmean, right? In this climmean it considers the use of 2 different parameters, 2 different parameters that are given, which is the name of the data set we want to use and the variable we want to compute the mean, right? So here you can see inside the function we are using the function again get.nc, this function that gets the information we are going to get and we are going to use here, and here to compute the mean of this data downloaded from the dataset is using the function apply, the combination of the apply and mean function. This apply function allows you, it's our function that allows you to use a function over a dimension, a specific dimension of an array. For example, we are using the apply function we are going to apply this mean function over the array data, maintaining the dimensions, the first and second dimension. As we said before, we print data, we said that it contains the information of latitude and longitude, and after that the information, the dimension of time. So we are keeping these two dimensions and applying the mean along the third dimension, that is the time. So with this function, we can define this function cleanMean, and then we can use this function cleanMean to the dataset and to the variable we are working with by default, and we are creating this mean array. Here you can see the dimension of mean. It has two dimensions with the size of the latitude and longitude. We have removed it since we have computed the mean along the time dimension. We are removed the third dimension of time, right? So once we have this value, this array with two dimensions, we can plot the map of this array. And to do that, it's very interesting. First, since we are working here with an array, before going to trying to plot the map, it's interesting to format the data, because usually plotting functions works better with data frames, data stored in data frames. For example, here, if we print mean, we see that the mean is an array, but for plotting functions, it's useful to order this data, including the information of latitudes and longitudes, and including also this information in format of a data frame. So we have defined this new format, df, format data frame, that is a function that gets these three parameters: information of data, any array we want to plot, the information of latitude and longitude, and it also uses some different functions like read that repeats in latitudes and longitudes, creating two-dimensional arrays, and also the function as vector that converts the information of that data into a vector. And we use also the function data frame that gets the information of these latitudes, longitudes, and values. So it returns a data frame. So well, with this function we can run this block of cells. So we have loaded the function in our environment, and we can apply this function to the mean we have created just before. And if we print the head of this data frame, we can realize that now we do not have an array. We have a data frame with three columns, x, y, and values, and three ordered columns where we get the first value is the value of longitude, the value of latitude, and the value of the variable in this grid point. So once we have this formatted as a data frame or data, we can go into the next section or subsection where we define a plot map function. Here we are trying to plot our result. So we have defined a function that gets information of the data frame. We want to plot. So since we have already created a data frame, mean data frame here, we can call this function with the name of the data frame. So it includes all the functions needed to plot a map of this data frame, considering it contains 3 different columns, x, y values. And it uses some different functions from the library ggplot2. As you can see here, we have the function related with ggplot. For example, we are using this geom_tile function to plot the data as lines, and also include here we include the information functions to define the color scale options, and including the country layers and latitude and longitude limits, for example here, etc. And other aesthetic options like this function, etc. Well, in this function we can load this function and we can apply this function. So as you can see here, this function gets as mandatory just one parameter, which is data frame, and it also has different not mandatory optional parameters that are the title and the subtitle in the figure and the caption and the variable. Here this information is only additional information in the plot. We can run this plot map function. And as you can see here, we have the result of our map. You can see we have created a map of the total column nitrogen dioxide, and here you can see we have included some information that are the texts that appear in the title, subtitle, and also the caption. Or here in the variable, we are including the information of the units in the color scale, for example, here. As you can see here, we are using again the function to get the information of different attributes in the variable we are plotting right now. So we can include the information of the attributes directly in our result, right? So we can get information of the long name as the title of the map here, total column nitrogen dioxide, for example, here. As you can see, this result is an expected result. This is the mean value of total column nitrogen dioxide in the file, and it's strongly associated with cities, the presence of cities and industrial regions, like here in the center of Spain or in the Mediterranean coast. Oh, now we learn we have 2 functions, 3 interesting functions. A function that allows us to plot a map. We have a function to format our data into a data frame, and also we have a function that allows us to compute a climatic mean, right? So once we have learned how to do this, we would be interesting to plot the other variables, to start working with the other variables, but we could use this plot map function, this combination of these 3 functions to plot the other variables. But since we do not want to replicate the code, we can define a new function that we have called plot air quality. This function will have as parameters these 4 parameters, the data set we want to use, for example, and the variables list. Here you can see we have created the parameter var names list, and that contains a list of variables inside the file, tcco, etc., tcno2, no, and so2. So this function will create a figure with different panels, with 4 panels, and in each panel we will include a map like this for the different variables we are including here. As you can see, this function contains a loop here where we are getting where we are computing the climatic mean here, where we are formatting the data using the format data frame, and we are plotting the information of the map of the data using the plot function. Here we have included the possibility of change the functions we are using to plot the map, and also to compute the mean along the time, because as we will see later, we will change these functions. So here we are accessing in the function, it accesses the information in the data set, it accesses the information of latitudes and longitudes, and after that it creates final different plots. Let me run this function and we will see the result, and I explain a little bit. Here you can see there is a line where we are using this plot air quality function using the data set we are working with, the list of variables we are working with associated to our file, and we are using for the temporal the mean function, the clean mean function, the function we define to compute the average along the total file, and also we are using the plot map function to plot our result. So we can run this function. Sorry, I didn't run this line before. So we can run this function here. And here it is the result. We are applying the functions clean mean and plot map to create the map of all variables stored in the data set, and we get the information of total column carbon monoxide and total column nitrogen dioxide and nitrogen monoxide and sulfur dioxide, included just in one figure with 4 different panels, right? We have a climatic mean of these variables, and well, now we can continue since we have the information of these functions. We have defined these functions. We can start to play with these functions, getting more information from our dataset. Well, we have learned how to plot a climatic mean of the dataset. It's very interesting information, but this is not related at all with the wildfires. That is the topic of this presentation, of this tutorial. So we are going to start to work with specific events of forest fires. And here we are defining a new set of parameters. Here we have this parameter associated with the dates where occurred 2 forest fires in this region in Portugal. Here, the fire of Pedrocal that occurs in 2017 in July, and also the wildfire of Loxacio in Spain, in Zamora, that occurred in 2022, in July and August 2022. Well, here we are proposing these 2 events. So this tutorial, you can run this tutorial using one or the other event. For example, here you have a wildfire. This is the wildfire you are going to work from now. You can define to this variable to work to make the analysis over the Pedrocal wildfire or over the Los Sacio wildfire. You can change this as before. You can comment this line or comment this one, so you can run the tutorial over these 2 different forest fires. I'm going to work with this Pedrocal wildfire, so we can run these lines. And here we we are just defining the initial date and the end date of this wildfire event we want to study. In this case, since I have decided to work with Pedrogal wildfire, when we print this date ini and date end, we get the starting date and the finishing date of the Pedrogal wildfire. Well, we get these parameters, and here we can compute. We are going to compute the average of over a specific period. In the previous example, we compute the average, the temporal average over the full dataset, but now we are interested not to compute the average over the full dataset, but we want to select some specific period inside the dataset, and we want to compute the mean over this period. So we will get information of these four air quality variables over averaged over this period. So to do that, we are going to define again a new function that we have called period mean, and this variable uses as parameter the parameters as before, the name of the dataset and the variable name, but it also uses two global parameters that are date ini and date end, right? So this function is pretty similar to the one we defined before for computing the mean, but as you can see, it accesses the data as we did before, and it also uses the information of time. So it has to format the information of time into dates, and it finds the indexes using the width function. It finds the indexes of the date array that are between this date ini and date end. So it is selecting the indexes that meet the condition of date is equal or greater than date ini, or less or equal than date end, right? So we are using these indexes to select the data we want to plot. We want to compute the mean. So we have created here a subset of the data using just the specific elements we have previously selected, and then we can right now apply the function mean as we did before, but this time we are not using the full dataset, we are using just the subset we created before, right? So this function allows us to compute the mean over a specific period, right? So here we are applying the function over our data. You can see here we have the period mean function applied over a dataset, and using the variable name we are using as default. And we are creating this array wildfire mean. And as before, we can do the same as than before. We can use the format data frame to give a format to this array. So we will be able to plot this data frame, this a specific variable, and we can use the function plot map previously defined to plot the result. Here it is, you can see the result, and now we do not have a climatic result. We have a result associated to the Pedrogal wildfire. You can see here that we have the concentration, it's not a concentration, it's the amount of the total column of nitrogen dioxide associated to this period of time. And as you can see here in the region located around Pedrogal, we have very high values of this nitrogen dioxide, right? But well, since we have the function to create this function period mean, we can go back and use again this plot air quality function, so we can apply this function to create this kind of result for the variables inside, for all variables stored in dataset here. So we are calling the plot air quality function over the dataset with a list of variables, and also, but now we are not computing the climatic mean, we are computing the mean over the specific period we want to work with, and we are using the plot map function to plot the result. So we can run this line, and then we get this result. As you can see here, we have the result of the different variables as average in the period of the Pedrogao wildfire. You can see here, for the case of carbon monoxide, nitrogen dioxide, and nitrogen monoxide, we have very high concentrations of these pollutants here around Pedrogao. But for the case of sulfur dioxide, we do not have a clear signal of the fire. This is because maybe the use of this mean computed in the period is interesting, but can be masked for different reasons. So to try to get the information of how high is the air quality, how the air quality is affected by the case of the wildfire, a specific wildfire, we are going to try to use not only means, but we are going to try to use the computation of anomaly values. From a statistical point of view, the computation of anomaly is just the difference between a value and the mean of this variable, from a value of a variable minus the mean of this variable. So to do that, we are going to define a new function, computeAnom function, that will compute these anomalies. So it uses from a variable, a specific variable inside a dataset, it uses the climmean function that computes the climatic mean, and also the function of the period mean function that we defined before, and it gives the result, returns the result anomaly, which is the difference between the period mean and the climatic mean, right? So we have this function, and we can apply the function over the dataset in, for example, one variable like this. And with this, we have the anomalies computed for this variable in the specific period of the Pedrogao wildfire, and we can use again the format data frame function to format our result. And well, we could use the plot function, the plot map function we plotted before, but we are going to include some differences. These anomalies are referenced to the climatic mean. We can modify the plot function, so we can include this scale fill gradient. This scale fill gradient give us the option to define the minimum and maximum values inside the color scale. So we can define the minimum values as blue, the maximum values as red, and in the middle we can use white color, and we can include in the middle the midpoint is associated to the value of 0. So with this we are going to plot the negative values with blue colors and the positive values with red colors. Just let me to run this function, and oops, I'm sorry, I don't know if I already formatted these lines correctly. And now we can use this plotAnom function that, as you can see, it has the same format than before. We are using the data frame and also the value of the data frame, and also the different values for the title and subtitle and caption. And we can run this line, And here you have the result, and you can see here we have a result referenced to the climatic mean, and it is the climatic mean is represented by white colors. So here the values along associated to white colors at almost in the value of the climatology, but here you can see that we have an onset result of the pollutant associated to this specific period. And we can see in blue colors that regions that are associated with negative values of anomalies that are associated with values below of the climatic mean, right? Here we have a clear signal of the emissions or the air quality associated to this event. So, well, since we have this new plot function and this average function here, compute anom, we can apply again or plot air quality to all variables inside the data set. But now we are using the averaging function, compute anom, and plot anom to make the plot. And here it is the result. You can see here we have an onset, the signal of the air quality, the effect of the wildfire of Pedregal in the air quality in this region of the Iberian Peninsula, and also it's included for the fourth different pollutants, carbon monoxide, nitrogen dioxide, nitrogen monoxide, and sulfur dioxide. We have this signal here. And well, this is the final exercise of this tutorial. It's enough for today. We do not have time to run again this tutorial, but I would recommend to any user to run again this tutorial using the other dataset here, the dataset of emissions, and you will see that the results are pretty similar, but are presented in a different way because, as I said before, we do not are working with air quality variables. We are working with emission variables, so the result is more focused in the region where the wildfire occurred. Well, this is all for today's session. I hope you find interesting information and also interesting functions that you can get from the code we are providing and you can use in your own work. I hope to see you in the next video.